So, well, hi everybody. I'm sorry I'm late. I had a few issues. Welcome to the stream. I hope you can hear me. If you can hear me, can you maybe chat it up a little bit? Well, hi everybody. I'm sorry I'm late. I had a few issues. Oh, 24. Yeah. 24 people waiting. Should I tell them to do a refresh?
You can try to refresh in case the video is not coming up.
Okay, one viewer. Is that me? That's probably me.
This is concurrent. 27.
Oh, okay. All right. Well, I'm assuming you're seeing it. On your screen, you've got Jupiter and Saturn in the same field of view. Jupiter's to the right, and Saturn is down on the left. In fact, if you look close enough, you can see the rings of Saturn right down there. Okay, hold on. Technical issues. If you can't see me do a refresh, and I know that tends to happen. Okay. Hold on while I try to get chat working. Okay, everybody, we're back. Sorry about that. Since I made it for kids, the live chat was disabled. Try chatting now. I think chat should work. Thank you for all of you out there who are watching and giving me feedback. So what you're looking at right now is Jupiter and Saturn. Understand that conjunction happens once every year because Jupiter takes 12 years to go around the sun. Saturn takes almost 30 years to go around the sun. So Jupiter laps Saturn's orbit every year in 1 month or so. But they never ever get this close until every 800 years or so, 4 to 800. Hasn't been this close since the 1680s, actually. And so we are in a very magnified view right now. This is about 180 power through the telescope. I'm going to try to stop it down a little bit so you can see better detail. You get a little more on the rings of Saturn. Let me zoom in on Saturn for you so you can see the rings. It's a little wavy. It's really low in the horizon. Let me see if we can sharpen the focus on it. That's about as good as we'll get on Saturn. Let's go to Jupiter. Let me see if I can slow us down here on Jupiter. If you look closely, we'll be able to make out the moons. Let's see if we can get some of the banding on Jupiter. It's so low on the horizon, it might be really hard. There you get some red bands there you might be able to see. We don't want to get too low. So right about here, you see some banding, some red banding there. If Jupiter were higher in the atmosphere, we'd see a little bit more. Let's see if we can zoom out and get the moons. Let me take the box off. Here we go, a little brighter. Let me get it a little brighter. Here we go. You can ignore the red dots around Jupiter. Those are bad pixels on my camera. Let me see if I can center this up. Yeah, I have my son Alan here to field any chats if you have any questions, because I can't see the chat for some reason. If you look closely, you can see right down here is a moon of Jupiter, right here, and one right here. And the fourth one, I think, is going to be off to the side, but let me get a little more shutter speed here. All right, that's about all I can give. All right, hold on 1 second for a technical standby. Okay, I do see your questions now. If you guys have any questions, you can ask. So I'm going to look through my chat group. I just found the chats. Hi, everybody. I am in my backyard. I am not in the desert. Will they overlap? One question is, no, they're not going to overlap. This distance right here is as close as they're going to get. This is actually 1/5 of the diameter of the moon. That's how close they are. And I'll go to the moon after we're done. Once the planet sets, I will go to the moon and show you just how close they are when you look at the moon. One question is, how far away are Jupiter and Saturn? Jupiter is 5 times the distance from the Earth to the Sun. That's about 500 million miles. And Saturn is 12 times the distance from the Earth to the Sun. So closer to 12 million miles. Hi, Shane. Yeah, sorry about the the chat being turned off. I made it for kids, and I think that automatically disables chat right now. So like I said earlier, this happens, Jupiter and Saturn are in conjunction every year. So the fact that they're close together isn't a rare thing, but the fact that they're this close is a rare thing, once every 500 to 800 years. 1683, I want to think, was the date. I could be wrong on that. Maybe someone could fact check that for me. Was the last time in the Middle Ages. I'm going to see now that it's getting darker, we might be able to get a little more banding on Jupiter. Let me try that. See if we dim the shutter a little bit. You can see the rings a little bit better on Saturn. What I'm going to do right now, the software that I'm using allows me to take a video. And so I'm going to process the video and see if we can see the planets a little bit better. So bear with me here. If you have any questions, keep texting. Yes, roughly 800 years ago was the last time this happened. So let me get to a video really fast. So I'm going to record a quick video and then I'm going to process it and see if we can't get any better picture going on. Hey Nick, good to see you. Yeah, let me zoom in on Saturn was the question. After the video is taken, I'll zoom in. If you guys are able to see it live, whether you're outside or looking through binoculars, you can see Saturn just to the right of Jupiter. Our image here is backwards. That's because of the telescope. Turns everything backwards. But yeah, Saturn is to the right. The brighter one, Jupiter, is to the left. Now they're calling this the Christmas star, but the jury's still out on whether the Star of Bethlehem was really the conjunction of two planets, because as you can see, that's not a super bright star. Jupiter and Saturn are both pretty far away from us right now because of our orbit. And even if they were close together at their closest point, it wouldn't be that bright. Okay, time out for a second. I'm going to keep streaming, but I'm going to turn the mic off because I have to do some processing, so hold on. Keep chatting if you have any questions. Yes, someone clarified 400 years since they passed this close, 800 years since it occurred at night. Correct. This telescope, one of the questions was about me using it the last time. This telescope is my little planet and lunar buddy telescope. So probably if you saw a live stream last time, yes, it was the same scope. Oh, the question was the Christmas star. I had said that they were calling this the Christmas star, but the jury is still out on whether the actual Star of Bethlehem was was a conjunction of two planets. You can spin backwards on some software and see that Jupiter and Saturn aligned close, maybe 4 BC. Some have it at 5 BC, but no one knows for sure when the birth of Christ was exactly, so it's hard to tell what that Christmas star is. But today is the first day of the winter, well, it is the winter solstice, where we are tilted as far away from the sun as we will be. So it is kind of cool that it happens right on the winter solstice. One question is, how many moons do planets have? It depends on the planet. Jupiter has 4 large moons, which you can kind of barely see here twinkling next to it. Saturn has about 5 main moons, but they both have scores of other ones. So Jupiter has up to, I don't remember exactly the number, up to 40 or 50 little moons. Mars has 2, but they're more like rocks. We, of course, have 1. Uranus and Neptune both have several large moons. Pluto has none. So it depends on the planet. Miss Androff, I would trust you on those numbers, on the number of moons Saturn and Jupiter has. So I will default to Miss Androff on that. Hi, Aaron. And yes, looking with the naked eye, they do appear much closer for sure. So like I said before, this view on the screen is about 180 power, maybe almost 200 power. With my camera set up through the scope, I have a little eyepiece in there, so I'm actually magnifying it more. So as we increase magnification, they're going to look a little closer together, or farther apart rather, excuse me. Let me see if I can increase some exposure and get more moons on Jupiter. So Terrence, you wanted Saturn a little closer. So there you go. Let me change the exposure a little bit on that for you. So you can make out the rings a little bit. It's jumping around so much because the atmosphere is cooling down. There's a lot of wind in it. So it's almost like looking over a hot barbecue at the planets. That's why they're moving around and dancing around so much. One question is, what color are the planets? The planets are pretty much the colors you see right here. Saturn is kind of an orangey color. Jupiter is kind of a cream color with red stripes. Let's see if I can zoom into Jupiter a little bit. And it's so bright that there, yeah, you can see a little red stripe down here. Bands of Jupiter. But again, it's so low, it's difficult to make out a lot of detail right now. Magnification I'm using right now is about 180 power. We brighten it up a little bit more so you can see them both again. There we go. There's no ad revenue, was the question on this? No. Hey, Derek, it's good to hear you. Yeah, no ad revenue. Yeah, Saturn's actually a little easier to see the rings from a distance, not so close up. Let me see if I can find that picture that I just made. Stand by for a second.
We brought it in a wrap up. That's okay.
Question was, how often does it happen? This one happened, last one, this close was 400 years ago, but we got some good information from a very reliable source on the chat that according to NASA, it happened 800 years ago during the evening. Yeah, Derek, I doubt I'm that famous. Okay, hang on. I'm gonna mute out for a second. Again, I'm gonna try to find a picture. All right, just to change it up, I'm going to show you guys how I would process a picture here. I'm going to move this over to the screen. You can see it. So this is from the video that I took and we're going to see if we can make it look a little sharper and maybe get some more detail out of it. Ah, there we go. So you can see the rings on Saturn. Jupiter is going to look a little overexposed. But that gives you an idea of how we can take a picture and make it look a little sharper through a process called stacking. So you can see the rings much better on Saturn there. I cannot zoom up currently. But let me try to save this and maybe we can. Jupiter did not come out very good just because it was too overexposed. All right. So I will be done with that. Okay, so we're back. Question was, where am I broadcasting from? From my backyard. I haven't disappeared. I just went to process a picture. My son's on. Thank you, son, for saying it looks good. Yeah, Miss Androff is right. Someone asked how often this happens, and it happens every year, but not this close. So this is a special conjunction. If you look out and you see them right now, they're pretty much getting close to setting in the west. But Saturn is to the right of Jupiter in reality. If you look at my picture, Saturn's to the left, but that's because the telescope projects everything backwards. Let me make them a little brighter for you. Trying to get bright enough to where we can see all the moons of Jupiter, but the atmosphere is just too thick. Don't go away because we still have to go to the moon when we're done. Awesome. I'm glad you all have decided to join me for this event. In terms of actual distance in the sky, someone said, how far apart are Jupiter and Saturn at this point in their orbits? At this point in their orbits, whatever 12 minus 5, about 7 million miles, about 700 million miles away from each other in their orbits. I think I misspoke. Jupiter is 500 million miles-ish, and Saturn would be whatever 12 times 1.2 billion miles away from us. So I misspoke on that. But in the sky, these two are only 5 arc minutes separated from each other. That is about 1/6 of the diameter of the moon. The moon puts an angle of 1/2 degree in the sky, about the width of your little finger if you hold it up to the moon. And so it's about 1/5 of that, 1/6 of that would be about 5 minutes of arc. All right, let me let me run over to the moon really fast. We can always come back to this. Let me see how much time we have left Let me go to a simulation here. Here's a software simulation of what we're looking at currently. You can see it. This is a pretend sky and a pretend background, but if we zoom in, you can see Jupiter and Saturn in what they should look like. So we saw the 3 main moons of Jupiter on the screen, and then Saturn is right here with its main moon, Titan. So you can tell as we zoom out, they get pretty close together. And we only have about, I'd say 20 minutes left of them being up. Let me go to the moon. Hold on. For a slew to the moon. Things are going to disappear off of the screen for a second. Hold on. Slewing to the moon. Ooh, the moon is bright. Let me stop it down a little bit. All right, welcome to the moon. You can see on the north end some of the craters of our moon. Now, in terms of distance, if you're looking up at the moon right now, the distance from the end of this lunar sea right here, which is the Sea of Tranquility. By the way, that's where the Apollo 11 landed. Let me show the approximate landing site of Apollo 11 was about right here, I believe. It was either on this side or on this side. It could be turned around. But Jupiter and Saturn are about the distance from here to here. This is the same magnification we just got through looking at Jupiter and Saturn on. Notice this distance is about how close they are. I can't zoom out on the moon right now because I have a fixed eyepiece in it. But that gives you a good reference if you look up at the moon on the proximity of them. See if we can zoom in on some of the craters on the moon. Ooh, look at that atmosphere boil. Again, that's like looking over a hot barbecue at your friend on the other side. There's so much turbulence in the sky. The wind's blowing. There's a lot of heat given off by the land early in the evening. So that's kind of what astronomers have to put up with when they look at things, is that boiling atmosphere. Let me see if I can sharpen the focus a little bit. Yeah, that's about as good as we're going to get. So what we do to grab better pictures of the moon is like what I tried to do on the picture that I took of Jupiter and Saturn, which was take a video and then stack as many pictures as you can and sharpen them up. So let me show you this picture that I took here. This was from 1,000 frames of the video. I stacked 500 of the frames while you guys were watching. And you can see how much clearer even the rings get. A little more definition, a little more detail. You can see the moons of Jupiter a little bit better. Down here, Callisto, Europa, and Io. These things are dead pixels on my camera, so ignore those. But that gives you an idea of how much more detail you can get when you take video and then stack the pictures together. And what it does is it eliminates the boil that you see here in the atmosphere, that boiling look to it. Question was, am I using that big telescope that I had in the classroom? No. This is a little telescope I have under the bed. It's a 6-inch telescope. It's great for moon and for planets. There's a better view of the moon. This area, ironically enough, where all the craters are, is referred to by lunar geologists as hell. Probably for the appropriate reason that it looks like so many meteors impacted the moon at that point that it just destroyed any flat areas. These darker areas you see are the areas that have remained flat and without any asteroid impacts. So we call those Mare, which is Latin for sea, M-A-R-E, or mare. You Latin speakers can help me out. So this is, let me give you a little lunar geology lesson here. This is called the Sea of Crisis, this little almost perfect circle. This little guy is called the Sea of Nectar. And this kind of weird shaped one is called the Sea of Fertility. Sometimes they have a running theme. I have no idea why they went, hey, crisis, nectar, and fertility. Don't know why those three would go together, but I guess you can write a thematic essay on that. This large one right here is the Sea of Tranquility. That's where Apollo 11 landed. And this really nice looking one here is called the Sea of Serenity. And part of the reason they gave it that name was because if you notice, there's only one little crater. Let me bring this down so we can zoom up. One little guy, oh, maybe a couple of little guys, the closer you get. But notice how smooth it is compared to the other seas. I don't think we've ever landed in the Sea of Serenity. Let me go further here to the north. North is down in my telescope. You'll see more disruption here towards the bottom. And there are other lunar seas over here, but they're hidden in the terminator right now, in the shadow of the moon. Tonight's a first quarter moon. There is a sea that runs on the north. Let me see if I can see any part of it. A little bit of it starting right up here is called the Sea of Frigidity, or Frigid. I guess for obvious reasons. All right, there's the moon. Let's go back to Jupiter and Saturn and see how they're doing. So time out while I slew to the planets. And I may have to relocate them, so hang on. There they are. we are, back to it. Let me try to get them centered here. Yeah, you all are very welcome. Thank you for logging on and for giving me the time of day on this evening, for taking time out of your night. It's a really, really cool event. Things like this don't happen too often, but when they do come around and it's evening time and not like 3 in the morning, it's fun to be able to share it. So I'm very happy to be able to share it with you guys. I'll leave it on the screen here until it sets. Let's see, I got a house in the way, so it's probably going to go behind the house or a tree pretty soon. Let me check. Yeah, I got a tree coming up in about 5 minutes. Okay, I am beginning to lose these behind the tree. I'm going to go back over to the moon if you guys want one last look at the moon before you go. Hold on while I slew there. The moon. Let me tone that down a little bit. Here we go. By the way, one of the reasons you can see the craters so easily on a first quarter is because the sun is just rising on this area of the moon. And so the shadows are really, really deep, which allows you to be able to see how long the craters are and how deep the craters are. In fact, if any of my advanced math students are still listening, one of the labs we used to do when we were in class was take the shadow right here. Let me see if I can click on it and zoom in. And we could measure this shadow right here in millimeters on a picture. And then we can measure how far away it is from the actual terminator of the moon right here, and use proportions and a little bit of Pythagorean theorem, and we can actually calculate how deep those craters are. And in fact, that was the acceptable way to do it for many years, until we were able to land spacecraft and do radar imaging as well. Hi, Jordan. How you doing? Hi, Aaron. You still there? Any moon questions while you're all still on? All 63 of you? Yes, gravitational force of the moon is about 1/6 of the gravity on the Earth. So if you weigh 60 pounds on Earth, you'd weigh 10 pounds on the moon. That's why the astronauts, when they walk on the moon, they jump around, because they could never figure out how to walk because they were so light, so they had to skip. Of course, that all depends if you believe we really landed on the moon or not. For you flat earthers that are out there, you may disagree, but I tend to believe we really did. Well, everybody, thanks again for coming. I am going to end this stream and hope you all have a really, really Merry Christmas. Happy Hanukkah. I know some of my students out there don't celebrate Christmas, but happy Hanukkah to you. And have a great time off. Those of you who have school vacation. The rest of you who have to work this week, I'm sorry. But hey, thanks for sharing. And we will talk to you guys soon. Have a great week. Take care.